Hi guys. So we're going to continue on with pages 10 and 11 of the Unit 10 classwork packet. Once again, that is pages 10 and 11 of the Unit 10 classwork packet. I know we're probably all busy making TikToks and doing all kinds of dances and whatnot, but let's just get through this, shall we? Okay, so let's take a look at page 10, question number 7. Each of these problems is going to be similar, but each one's also going to require you to adapt the numbers and what you set things equal to the particular situation. All right, so let's take a look at question number 7. Number 7 looks something like this. All right, they give us an inscribed angle, and that's 8x minus 9, and they give us the arc that it intercepts. Now again, how you choose to set this up is up to you, but for the vast majority of you, I suspect it's probably going to be easier to say that it takes two inscribed angles to make the intercepted arc. So let's take a look at that. So it takes two of these to make this, right? So I got 2 times parentheses 8x minus 9 equals 158. Now some of you guys are in love with distributed property and you would just do distributed property all day if you could, right? In this case though, do you guys see a slightly faster way to get rid of that multiplied 2? I would agree. Probably dividing by 2, right? So if I divide both sides by 2, look at that. Say goodbye to that 2 over there. I believe that's 79. Gosh, I hope so. If not, uh-oh. All right. Yeah, it should be 79. And then it's a pretty easy algebra problem from there. Add 9 to both sides, so 8x equals 88. And lo and behold, x equals 11. All right? So notice, I couldn't tell you to set something equal to 180 or set them equal to each other or anything like that, but this is kind of like those triangle mid-segment problems we did where it takes two inscribed angles to make the arc. If you guys can remember that, all will be well. Let's take a look at another one. Let's take a look at page number 11, and let's take a look at oh, yeah, did I just write on my wall? Oh my god. Well, we'll deal with that later. Okay, page number 11, and we're going to take a look at question number 9. All right, so we're going to look at number 9. Now, number 9 is similar to a problem we've already done, right? Here's my center, here's my diameter, and then here is kind of like an inscribed triangle, right? And so they tell me this is 13x minus 1, and this is a diameter. So the key here is recognizing one crucial fact. A diameter divides a circle into 2 equal parts, right? If a circle is 360 degrees, how many degrees is each semicircle? Well, 360 over 2 would be 180. So this right here is 180, and now we're ready to set up the problem. How many of the inscribed angles, how many of those angles inside does it take to make the arc? It takes 2. So I'm going to set it up like this. 2 parentheses 13x minus 1 equals 180. Now, how do you guys want to get rid of that multiplied 2? Well, I'd say getting rid of it by dividing first would be a great move. So I get 13x minus 1 equals 90. Then 13x equals 91. X equals 7. I know I did the division kind of fast, and I apologize for that, but if you work it out for yourselves, hopefully not using a calculator, you'll find that it works out nicely. All right? Now, occasionally, what's going to happen is you end up with some additional steps. You'll end up with a multi-step problem where you have to bring in a couple concepts from this chapter together. Specifically, let's take a look at question number 11. Once again, what number? Question 11. All right. So number 11 is still an inscribed angle problem, right? All right, so we got something that looks kind of like that and that. They tell us that this is 92, that this over here is 162, and this is 7x minus 10. Now, I know just by looking at it that because this is an inscribed angle, it's going to take 2 of these to make this right here. However, did they give me this arc? Do I know how many degrees it is? Oopsie daisies. No, I don't. So what I would suggest is I'd figure out first how many degrees that arc is, right? So if I've used up 92 and 162, what do I have to subtract those from to figure out the missing piece? Add these up, subtract them from from 360. I apologize, right? 360 degrees in a circle. So I'd subtract, so add 162 and 92, 4, 5, 1, 254, and then 360 minus 254, 10, and that's 106. All right. Again, how did I get that 106? I know there are 360 degrees in a circle, and so I added together the arcs that I had, subtracted them from 360, and lo and behold, I have 106. Now, let's see if you guys can help me out with this. How many of these does it take to make this? Well, it's got to take 2, right? So, 2 7x minus 10s equals 106. Divide both sides by 2, right? And that would equal 53. Add 10 to both sides, 7x equals 63. Oh my gosh, look at that. Do I know how to divide? Yes, I do. And x equals 9. So notice, same basic principle throughout, right? Only difference was that we first had to use the fact that there were 360 degrees in total going around, all right? So that's like one of those big key ideas you guys want to keep in mind. In a couple other sections, we've talked about how you also need to know linear pairs, but the big idea for inscribed angles, you need to keep in mind that there are 360 degrees in total.